Hi guys, my name is Vinay Jain and today we're going to be discussing Leetcode question 112 path sum. So given the root of a binary tree and an integer target sum, return true if the tree has a root to leaf path such that adding up all the values along the path equals target sum. A leaf is a node with no children. So what is this question? So let's say this is the example tree that we have, and notice that these nodes, node 7 at the bottom of the tree, node 2 and node 8, these are leaf nodes, right? So a leaf node is a node with no children. So these are the leaf nodes, and let's assume that node 5 is the root of the tree. So the question is asking, we have to find a path which starts from the root of the tree and to any of its leaf nodes. So let's say this is one path, the other possible path is this path, and the other possible third path is this path, root to leaf node. So along that path, whatever nodes come along that path, you have to add them all up, calculate the sum, cumulative sum, and when you reach the leaf node, you have to check whether the sum calculated so far is equal to the target that you have or not. If that is equal to the target, return true, otherwise return false. We start from node 5. The node 5 passes this value to its parent child nodes first. So node 5 passes this value to node 4, which becomes 9. So this is the sum total so far that we've calculated along this path. Then node 9 now passes its value to its child node, which is node 11. So 11 plus 9 becomes 20. This essentially means this is the sum that we've encountered so far along this path, which involves these three nodes. And now we go further into the child nodes of this node, node 20 now. And 7 plus 20 becomes 27. So this is the path that we've encountered. This is the path sum that we've encountered along this path. And since we have reached the leaf node, now we calculate whether this sum is equal to the target that we're looking for or not. No, it is not. So therefore this returns false. And now we check its other subtree, which is this path. So essentially we check the other path, which involves this path, this highlighted path, and we pass node 20's value to its right child node, which is 2 plus 20 becomes 22. And now we check whether this is equal to the target that we're looking for or not. Yes, it is. So therefore this returns true to its parent calling function. So we're going to be using a depth first search algorithm using recursion. So we start from node 5. So in the function call stack, we start from node 5 and then we check its left child first. So this is the path that we're exploring right now. We pass the node's value to its child node. So 4 plus 5 becomes 9. So this is essentially the new node value. So which is 4, and we pass the parent value, right? So 4 plus 5 becomes 9. So this is the node that we're currently working with. And we then check, is it a leaf node? No, it's not, right? So we propagate into its child nodes. So now we're working with 9 node, but it's left child. So essentially this path now. We're working with that. What is the left node of 9 node? So that is 11, right? So we pass, so let's say we pass our sum so far, which is 9, to this node value, which is 11. So 11 plus 9 becomes 20. So this is essentially what it means. 11 plus 9 now has become 20. So this is the new node value. And now we're working with this node 20 and we check its left or right subtree. Since it has a left subtree, we check that first. So 20 left, which is 7. So this is essentially the node that we're currently working with. And we pass the parent value to its child node. So 20 is the sum that we've calculated so far. We pass that value to the child node 7. So this becomes 27. So this is essentially what has happened. 20 from the parent node value has been passed to its child node. So 20 plus 7 becomes 27. Now we check whether this is a leaf node or not. Yes, this is a leaf node. So we check whether this sum that we have encountered so far along this path, is that equal to the target that we're looking for or not? 27 is not equal to 22, right? So this essentially returns false. So this essentially returns false to its parent calling function, signifying that there is no such path found in this subtree. So this is returning false to its parent calling function. Sorry, my bad. 27 would return. This is essentially what from 20 left we have found false. And now we evaluate 20 right. So basically the right child of 20. So this is the path that we're exploring for now. So 20 right, which is equal to what? 2. So this is the node that we have, and we pass the parent's value, the sum so we have so far. We pass 20 to its child node. So 2 plus 20 becomes 22. So now since this is a leaf node, right? This is a leaf node. So we calculate what is the sum that we have found so far. Is that equal to the target that we're looking for or not? Yes, that is equal to the target that we're looking for. So this essentially returns true to its function. So now this is essentially replaced by this. So basically from 20 right we get a true response. This gets a true response for this path since we have found a target. Now the node 20 evaluates responses from 20 right and 20 left, since it has found the specified target, which is 22, in one of its subtrees. So therefore this returns true to its parent calling function, which is 9 left. So this then returns true to its parent calling function. Notice again how 20 evaluated its response. It would be whatever response it got from 20 right, or whatever response it got from 20 left. If it has found true in any one of them, it will return that response. So this essentially is now replaced. 9 left receives a response which is true, and since there is no 9 right to explore, right, 9 right is null, so we don't explore that. This node 9 then evaluates responses from its left and right child. It has only one child, and from that it receives a true response. So this is essentially also replaced by true, since this also returns true response to its parent node calling function, which is 5 left. Since these have returned its values, these will be removed from the call stack. And this is essentially what we have so far. From 5 left, we get a true response. We do not end the algorithm now, since we still have a 5 right response to record. We still have a right child left of node 5 to explore, so we cannot end our algorithm right now. So 8 plus 5, as I said, the algorithm would proceed like this. 5 right is 8, right? So we pass whatever sum we have encountered so far, which is 5, and that equals to 13. So this is the new node's value, and node 13 is a leaf node. So we check whether this is equal to our target or not. No, it's not. So this returns a false information to its parent calling function. So essentially from 5 right we receive a response false, and now node 5 evaluates responses from its child nodes, which is 5 left and 5 right. So this essentially evaluates 5 left or 5 right. So it received a true response from 5 left. So therefore this then returns true to its parent calling function, which can be the main function, and this is essentially removed from the call stack. So this is how the recursion algorithm works. I just wanted to take time to show how the recursion algorithm works using the call stack, and also by showing a dry run of this, just for the understanding purposes, because I understand how recursion can be a bit confusing for people. So now that we have understood this, let's see the algorithm for this question. So the recursion algorithm is, if current node is a leaf node, so this would be our base condition. Every recursion algorithm needs to have a base condition to stop the recursion from going into infinite recursions. So if current node that we're working with is a leaf node, that means we have to equate our target sum. We have to check whether the sum that we have so far is equal to the target that we are looking for or not. So we return if the node value that we have so far, which is the sum of all the nodes in the path, is that equal to the target or not. If it is, then return that. If it is not, return false. If we have a left child of the node, that means we haven't reached the leaf node. So what we do, whatever node value we have encountered so far, whatever the sum we have encountered so far, you pass that value to its left child, and then recursively do the same thing in the left child. And whatever response you receive from the left child, true or false, you record that response in, let's say, a variable. If we have a right child, let's say, of the current node that we're working with, that node's value, the sum that we have encountered so far, you pass it to the right child, and recursively do the same in the right child. Whatever response you receive from there, you record that in, let's say, another variable b. Once this recursion part has been completed, then in the end you check if you found an answer in left or right subtree. If you have found an answer in any of these, let's say if in one you have found true, so then you return true. If you haven't found true in any one of them, you return false. So this is how you do that, A or B. So whatever response you have received from left, or the response from left, or response from right, you return that to the calling function. So this is how the recursion algorithm works. I hope this dry run and the explanation of recursion algorithm, also the demonstration of how the call stack works, helped you understand how we can use recursion and depth first search to solve this question. Thank you for watching this video, guys. Have a nice day.